Hello and welcome to a quick rundown on some of the fundamental concepts behind a database. Um, for this section, we're going to be using as our example software LibreOffice Base, which is part of the LibreOffice software suite, which is an open source, free software, like productivity software suite. So it's like Microsoft Office, only it's free. And there's a lot of similarities between LibreOffice Base and Microsoft Access. In fact, to the best of my knowledge, I looked and looked and looked. I can only find these two. These are the only two programs that do what they do, which is to say offering a kind of a complete database solution on a desktop that's relatively easy to use and doesn't require a whole lot of specialized knowledge. In every other database engine, you have to build your own interfaces. You have to do a lot of programming, and well, you don't have to, but it's almost always required that you know some amount of coding in order to build a like a web-based database or something like that. Ideally, Base and Access are kind of geared towards like small businesses, like keeping track of customers, keeping track of like transactions, things like that. It's this kind of all-in-one database solution is useful for like the small business kind of sector. If you're going to get too big, you're going to want a much bigger, more robust database system, probably one that's more secure. Not saying you can't secure a base database, but it is not. Its security wasn't its number one priority. So let's look at the slides here. So what is a database? We're going to define that. I guess we've already covered some of the background on LibreOffice Base, and we're going to look at a couple of different examples of what a database looks like. So we're going to just do this as a brief overview, just to kind of get the idea of a database in your head and give you a sense of what it is that we're trying to accomplish here. I don't know why that already animated. So a database is this like stack of hockey pucks thing is sort of the standard iconic representation of a database when you do like org charts and things like that. So it's a collection of data stored on a computer. That's it. The file system on your computer is a database. So all of your files are in a database. What we usually mean when we talk about a database is something that has some kind of list of records for something. Like usually we would think of like a customer database or a product database or something like that. Facebook, Twitter, all of those companies, all social media companies use a database in the back end to keep track of all your posts and cat pictures and all that stuff. All of your dank memes. A database also has to expose some kind of interface in order to interact with it. You need to be able to do things to the database, add new records, search and sort them. Oh yes, it's on the next there. Searching, sorting, indexing, that is like making it easier to search and sort, and then querying, which is looking for specific records in the database that match a certain criteria. Like searching for someone's name and finding their name and address or whatever. So the fundamental unit of a database is a table. So you create tables that are basic. They're lists. It's just a list, but each item in that list needs to have very specific requirements. So each item, before you can deploy a database or start adding things to it, you have to decide and very explicitly define what an item in this list is going to look like. It has to have these specific pieces of data, or else it's not a valid entry in this database. So like if it was a customer database, it's got to have the customer's name, their address, their phone number, their email. It has to have all of these little bits of information, or else we'll reject it as an entry in this database. Consider like the last time you went to the doctor's office. You walked up to the counter and the receptionist says, what is your usual? This is at least at Sanford. This is what they do. They say, "What is your name no, they say last name and date of birth. So they're asking you for two pieces of information. For whatever reason, they have determined that those two pieces of information uniquely identify almost all of their customers. And so basically what happens is it goes through their entire database, looks for whatever patient, whatever entry in their list of customers, patients, has that last name and that date of birth. Now, if there are multiple people, they'll ask for one further piece of information, maybe your first name. And usually those pieces of information can uniquely identify what customer they're looking for. It is also possible that the people who designed that database created indexes based on the last name and date of birth thing, which is pretty likely. It makes it so that it's faster to search on those two particular search items. So let's say you're a vet. You're a veterinarian, and you keep all of your information for all of your customers and stuff stored in a set of notebooks and ledgers, paper. And you've finally had enough, and you've decided it's time to modernize. So if you were going to build an actual database for that business, what might it look like? Well, I guess we have to decide what tables we want. And let's start simple. Let's say we have these two. We have a list of customers and a list of pets, because those are kind of the two things that we were going to be listing. Those are two things that we have a lot of. We have a lot of customers. We have a lot of, and those customers have pets. And each customer might have multiple pets. That's why you can't necessarily put the pet in the table with the customer either. So each list, let's see. For the customer list, you might ask, you would want demographic, contact information. You would want their name. You would want their address, phone number, an email address, possibly a link to some billing information, maybe some billing information there, something like that. And that's it. You don't need anything else for the customer, because in your pet list, you're going to have a reference to the customer that owns that pet. So in the pet list, you're going to have the name of the pet, when it was born, what species it is, what the sex of the animal, and who owns it. And that item in the list will just be some reference to the customer that owns that pet, the customer item in the customer list. So this is what we call a relational database. So we're going to work on building these kinds of schemas. As your database grows, you're going to find that you might need more tables. Maybe you're going to need a table for listing all of the vet visits. Now, this will be linked to each pet. So this pet came in for a visit, so we have a list of all the visits that this pet had. Oh, here's a list of all the prescriptions that this pet has been subscribed. And here's a list of all the invoices that are going to be linked to both a visit and a customer and possibly a pet as well, so that you can, accurately bill a customer. Whoops, I have some bullet points here. Yeah, so more lists. Each of these lists is going to be interconnected. They're all going to be related to each other, and they're all going to have some sort of it creates like a web of relationships between each of these tables. So the invoice table is going to be like, okay, you owe $500 for this animal, and this animal is linked to this customer. So you can always trace back from this list, from each item in this list, to find who owes that money and whether or not they've paid it yet. So in base, this is kind of what it looks like. You just have a list, you have a table, you have a list of their names, their phone numbers, address, city, state, email, that sort of thing, contact information. It might not surprise you that it looks kind of like a spreadsheet. And that's not by accident. The spreadsheet is actually a kind of database. It's called a flat database. It's not a relational database. But it is a kind of database, a table-based database. So each column is actually... So when we define a database, we have to define its schema. It doesn't notice that the rows don't have the numbers, the columns don't have letters, they actually have names. So in this column, I have a specific kind of information that has to be there. In this column, I have another kind of information. In this one, I have a different one. And you can even restrict to make sure that it's a valid phone number. You can actually create restrictions for what kind of data goes in any particular column to make sure that it gets validated correctly. So in the ID column, we have a number, some sort of unique identifying number. It doesn't mean anything. It's just a unique identifier. It's usually what the table will build a index on, so that you can reference the customer from a pet or something like that. This is just a text box that is going to have the name of the customer. These ones will also probably all be text boxes, but you might have some sort of extra validation to make sure that this is a valid email address and something like that. We're not going to go over like validation, data validation so much. We're going to do a little bit, but not much. We're not going to make sure that email addresses are correct and things like that. But that's about it. That's like the basic kind of like rundown of what a database looks like from a very high level. We're going to dig in a little deeper and get real close and build an example toy database. But first, in the next talk, we'll look at what are the basic elements of a database. We'll see you in that video.